Okay, I'm going to create some instructional videos here since I can barely breathe, but here we go. So p squared equals 25. Now, we can solve this algebraically just by taking the square root to both sides, because the square root, let's rewrite it, the square root of p squared, we should know, is just p. So whatever I do to one side, I have to do to the other. Now the square root of 25, I know we've been saying that this is just 5, but from now on we have to think of this as plus and negative 5. So positive and negative 5, that's what that symbol means. And that's my answer. Because if you think about it, negative 5 squared is also 25. And obviously 5 squared is 25. So we have two answers here, and we need to think about the positive and the negative root of 25. So the other way we can look at this is if we set this equal to 0, that's p squared minus 25 equals 0. If you think about graphing this or factoring this, this is p plus 5 and p minus 5 equals 0. And those are our zeros, so it crosses at 5 and negative 5. And the y-intercept is way down here at negative 25. But regardless, we have this. That's just a quick sketch of it. All right, but that's how we solved it previously, is we actually factored this, and we got p equals negative 5 and p equals positive 5. So it made sense back then that we had two different answers for p. We had positive and negative roots. So when we solve algebraically, we need to think about both roots also. Okay, and then this right here, when there's a constant or anything else with k squared, we have to follow the order of operations using PEMDAS. So parentheses, exponents, multiplication, division, and then adding, subtracting. So we're going to get, we're going to undo the equation by following PEMDAS backwards. So we're going to get rid of addition and subtraction first, and then worry about the exponent. So don't go square rooting this until you get rid of the 10. So subtract 10 from both sides. Now I have k squared equals 58. And then again, I'm just going to square root both sides. And k equals, now 58 is not a perfect square, so I'm just going to leave it like that. Now I want to check and make sure that there's no perfect squares that go in to 58. So 58 divided by 16, that doesn't work. It isn't divisible by 4, so I think we're pretty good. I do not believe that's divisible by a perfect square. Now, the only thing we have to be really careful of is that when I find my answer, I got to write plus and negative root of 58, square root of 58. So that positive and negative sign is very critical.